Today I prepared example that is generalizing using databases in terms of searches and pages, for searches and pages. In this example, searches are relatively simple, but it does show some examples. If you compare to previous lesson examples that was borrowed from video tutorial or LinkedIn Learning, slightly changed, but mostly borrowed. This example has simpler searches, but in more complete example. So it is integrated. Unlike in the previous case, it was just one method call, and this is it. In this case, it's a program that tries to imitate what is in reality, but definitely it's not a real-life program. It is just a demo that tries to imitate it. It does contain real data, but this data is out of date, so don't refer to it. So let's clone it and see what it does. This program is using templates because we still didn't learn how to do clients, like separate programs that interacts with web service. So it is using templates and Java Persistence API or Jakarta Persistence API to do database queries. It is also using in-memory database H2. We will switch to using real-time, not real-time. I shouldn't use real-time, like real. A real database. Why I shouldn't use real-time? Because real-time, it's a name of database. So real-life scenarios, like using MySQL. API is the same, except we need to set up a connection to MySQL if we install MySQL. And network configuration, so it does connect to right place. So this will be a real difference, but Java code will be the same. So let's clone it. This is doing H2, so we don't need to install database separately. So let's clone it and see what it is doing. So clone repository, and this is probably 29. And Command V. CourseListDemo, SpringBoot. This program is listing courses. Courses and numbers are real, but it's out of date. It's a couple years old. So clone. It is Sheridan courses from Applied Computing. Last project. So in order to do searches in some meaningful way, we do need to have some data more than like 4 items. So I really needed to load some table in order to show searches, especially if we want to display data by pages. And the result of the search is by pages. Because if we want to display data by pages and result of the searches by pages, 4 items or 6 items is not enough. So for this reason, I needed to load some data. So what did I do? Since it's in memory, it has to be loaded each time. And in static, there are resources. This is just inserting footer. It's not really, it's not client, it is just footer. In resources, if we open it, we will see that data is not in the SQL format. Data is in JSON. So definitely we have options how to load JSON, and I picked the one that was kind of on the surface that wasn't difficult to look up how to do it. So what is the origin of the data? Those are applied computing courses from Sheridan, and it is only name, number of the course and name of the course, but definitely there are more options. So it is doing searches by two options. Actually, it's only one by this one. And it is displaying data by pages. So where this data came from, I definitely didn't type it. It was just XML page, and we can load XML into MySQL using GUI that comes with MySQL. It is called Workbench. Once it is loaded, you can export it into JSON. So this is what I did. So I loaded XML. I loaded Excel. No, I think I saved Excel as comma-separated file, something like this, and loaded using GUI of MySQL into database and exported back as JSON. So to avoid typing really long things, which is not huge, but it's long. So this is resource of something that comes as it is, but program should be able to process it, so it is inside of resources folder. So next step is to somehow load this file into database. So I have used the same approach as before in other examples. I created init database component. Since it's component, it will force system to create the object and to make it injectable. But in order to create this object, it has to call constructor, so it needs to create repository object and provide it as dependency to the constructor. And after constructor call, system will execute post-construct method. Name of the method doesn't matter, but what it matters is that it is post-construct on top, so it will be executed after constructor. And after this, I look it up how to load JSON file. So of course nobody is born with such knowledge. We have to look up how to do things. So I was Googling how to load JSON file, and eventually I found it. And as you see, there is a try and catch block. And we didn't see this so far, and it's one of the reasons why I have this example, is to show that some exceptions must be caught, and those exceptions are called checked exceptions. And they must be caught with try and catch, or must be marked as this method throws exception. So it will be like throws and name of the exception. So one of the two. So if I try to remove try and catch around, code will be underlined in red, so it will not compile. So it is one of the features of OMIS features of Java, checked exceptions. There are some exceptions that inherit from checked exception a class, and that must be code, otherwise it will not be compiled. Other languages do not have it, and the reason for it, it's not such a great feature to have. Checked exceptions was introduced in Java as something designed to be good, but it was quickly realized by programmers that it's only creating issues, it's not actually solving them. So since it became part of this Java standard, checked exceptions, and historically it's hard to get rid of them, so they're still around, and somehow religiously enforced by compilers. Typically, all checked exceptions are related to either operations to files, operations to network, connections, or databases. So in this case, we have all three. So it is either files or databases or networks. And this is special kind of try and catch. It is try and catch with resource. Also didn't mention in this course. And this is part of the reasons why I have this example, is to show try and catch with resource. It's also a feature of Java, only feature of the Java. I don't think that this exists in other languages. How it works. This try and catch block has catch, obviously. It has try option. And if it is throwing exception, it will be caught here. And this part is called resource part. And again, it's a feature of Java. How it works. If we open some resource here, like network resource or file resource like this, assign it to the variable, when exception happens, this will be closed. So system will call close operation on file object. So it will execute .close method. So this is the behavior of it. There is definitely another way to do it without resource. So this is called resource. So it will call close operation on file object in this case. Another way is to do a try catch with what is the last one? Oh, I forgot 1 second. I use one more block that will be executed anyway, even after catch or try. I forgot what's it called. Try catch and remember your C#. What's it called? No, something like final. Well, let's try. Finally, maybe. Let's try. Yeah, finally. Not final, finally. This will be another option. So instead of using resource, open it outside and close it in some block that will be, finally, that will be executed anyway. Even catch or no catch. So this started like relatively recently, like Java 7 or close to that. A version before it was with finally. We had to do finally to close it. So let's delete this one. So this will not work by default because I'm using library to process JSON that is not added by default. So where it is in build Gradle, I added library, JSON library. JSON library is done by Google, so it is one of the standard libraries typically used for similar tasks. And it is not the only library to process JSON. There are multiple ways, and this is one of the 3 popular ones. And it's also a demo how to add additional things. You just copy-paste it, and before copy-paste, you need to know what to copy-paste, so you Google for it. So this file is definitely editable, and if some extra features are necessary that are not selectable in the menu, in the dialog when you create the project, you can just look up what you need, copy-paste it, and put it here. So this is how it was done. So I open it file and buffered reader. What is the difference between just reader? And this is file, it's low-level API to make it writable and readable. And buffered reader make it more efficient, so it doesn't read by just information that you ask. It will read a little bit ahead of it. So next time when you do read operation, it will delete from memory, not from hard drive. So it is for optimization. So what happens next? We need to process what we read, because this is just reading into buffer. And now we need to make sense to split it into objects. So this library is converting strings that we read into objects of Java. So it is doing this brute force operation under the hood to create a list of objects according to description. How does it get description? It is getting description from reflection, because every class, after it is compiled, and every object in the code created from the class does contain description what is inside. So it is taking information from the objects that I provide, so it knows what kind of data fields it needs to extract directly from the compiled class. In this case, array list of courses. Course is compiled, array list is a library, so it will pick description of the objects that it needs to create from course and array list. So get type will provide on description of it, and next operation will create a list of courses based on the description using object JSON that comes with the library. So this operation is quite common in Java world and in languages based on Java. When we create objects based on description using some other objects that comes from a library. If you took Android course, you probably notice that there are similarities, that when we receive a JSON from internet, we could convert it into tree of objects, describe it in JSON. But objects that we create wasn't JavaScript object. In JavaScript object, it is relatively simpler, because we receive it as a string, and there is a built-in JavaScript operation that parse, that will take the string and create list of objects, JavaScript objects out of it. But similar features exist in other languages that come from standard libraries like this. And next, I call save all operations that takes list of objects. And this is implemented by default in repository, so it will save those list of objects into database. So this is how I populated it. It appears like it is quite a task, because I have a file of one format. I need to put it into the database, but since I'm using standard libraries that came with SpringBoot, surprisingly, all code is just less than 10 lines. In order to get the file, read the file, convert it into objects, and put it into the database. So this is how database was populated. If we run it, we will see that that if we open H2 console, we will see the data in the table. It is quite long data in this case. So let's do that. Localhost 8080 /H2 console. And going there, we will get course table. And this table is created based on not the code, definitely not the code in initialization, because in order to insert into database should exist. It is created based on description inside of entity file course. right? So system is created this table based on description in Java file, call it market with containing class market with entity. And this is done by default. And so if you don't say Hibernate DDL auto none, it will do that. Okay. So what is inside of the course? When we create tables this way, only thing that is required, two things are required, is entity and ID. Everything else will be just done by common sense based on the name of the classes, name of the variables inside of the class. So as you see, there is no table name because it will use name of the class. This is generated, but I didn't specify type of the generation because I'm not using SQL. I use default writing, so it will use the same counter, so I don't have to worry. So if we compare files that are using SQL in order to initialize database, in this code, you will see that I didn't specify the type how I generate ID. And the reason is that we just need to be consistent to use the same kind of generation ID. And it will be consistent because I insert data using the same code. So it will use the same kind of generation. Previously, I didn't have this luxury because I inserted some data using SQL and I inserted some data using Java. So I had to stay consistent. So you have two data fields called code and name, populated the way you saw by calling just one method. This is not using shortcuts as what is called Lombok. So this is why I had to generate constructor, no argument constructor, setters and getters. This is required and these are required, and the reason for it, because system calls constructor after this, it's calling setters. And it needs getters to display data inside of template. So what do we have here? We do have controller that is using template engine in order to create what is asked. And this is a little fancier controller, although it is not doing updates, it's only displaying data. It is a little fancier because the behavior of the template is fancier in this case. It needs to do some searches and also some displaying data by pages. So let's see what it is doing, what it does. So in localhost 8080, we have index file, which is kind of table of contents, what is going on. List all, it is just to see that I populated database, but we can see that database is populated by running select all from this. So it is 104 entries. So it's not very long, but good enough to display data by pages. So what happens in select all? What's this? List all. List all, it will display all the data. So list all goes to address list all, sends get request to list all. And this template uses CSS and data to display this stuff. So let's see what happens inside of list all. So this is address, list all, this one. So request comes to list all, here it is. System is using get mapping because it will be get request. So it will call given method. So what happens here? I call repository find all, that will give us list of courses. And I'm returning model and view that will contain name of the template and the list of courses marked is, this is a variable, and this is the name inside of the template. So template is list all courses. So let's see that template. A list of all courses. A list of all courses. Right? And this JavaScript is just to insert footer. So what do I have here? I have table with table row at the top, count code course. I'm explaining this one because I will repeat the same logic in other templates that I found here. So, and then table row is repeated using for each loop. So this is what is the source of iteratable course. No, sorry, this is the source of iteratable. This is variable, loop variable, one at a time from it. And second parameter is optional, and it is used to display count. So you see I count is first column. After this, we display course and name. This is the fake data. And the fake data will be displayed if you open template directly in the browser, so this will be fake data. Right. Or you open HTML by double click of HTML file. So it will be the same behavior as clicking this icon. This is not executing Java, it is executing just HTML. So you will see fake data in this case, this one. Indefinitely browser on its own does not understand this one, so it will ignore it, so it will show fake data. Otherwise, we see when we execute it on server side, we see list where that, I don't see where is this. List all. Yes, this one. We will see the list displayed by the loop. So definitely this is not using any kind of pages, but next step is to see this one. This is not using pages. It is just next step of complexity is list by codes. So let's see. So at the top, we have a navigation bar implemented brute force by links. When we click math, it is listing all courses started with math. Let's click PROG, listing courses starting with PROG. APL is listing courses starting with APL. Obviously, it is some kind of search against the database. Start with, this field start with. So in order to execute this search, we need to provide some kind of input of what we're searching for. So here is the link, and these links are going to the address list by codes and part of the data in the address line. So we learned that this, when we insert some data in the address line, it's called path variable. So this is the path variable, and we have links to places that has path variable in it. Right? All of those addresses are going to list by code and /code. So if we compare the same logic to student data example, we had student details /ID of the student. So what did we do? We used get by ID, and it gave us option to get it. That was default method of the database, get by ID, and you get it, right? There is no such method, get by course code, so somehow we need to use search using logic that we learned before. So let's see how it is done. It is list by code. There is without ID and with ID. So as you see, it would even work if we don't provide ID. But what would happen if we don't provide? It will send redirection to the browser. What is redirection? It is telling a browser that this address is not really what you want. You go to another address. It is like calling support, but they will tell you call another number instead of connecting you directly. If they connect you directly, it will be forwarding. If they give you another number, so it's totally wrong number, call this, dial this number, it will be redirection. So browser will receive new address and it will send new request. Just because browser will send new request, you will see this address. So it will be redirection to the new address. So if I delete this part, I get redirection to new address. So browser received redirection, and after redirection, it sent new request. So a browser displays address of the last request. So this one, plus data, additional data. So in this case, it is address of the last request. When we deal with pages, you will see this additional data like page number in it. Okay, so what do we see here? When we click on it, definitely it goes to new link, and definitely that this is not link after that. So somehow what is clicked should not be displayed as a link, because it's technically we can, but it will be nicer to show that this is not a link, so it is current search. So template must have a logic of inserting values here that will end up in the address line, and also logic to not to insert link when we are currently at that address. Right? So let's see how it is behaving here. So it is redirection if we don't specify address. It is redirecting to a list with address. Okay, so that would be list, and this is path variable. So I call it this path variable letters, and if I don't want to provide additional instructions, it's a variable name given as a parameter to the method, letters. Okay. So this is how I extracted this search parameter from the address line. Okay. Our model parameter is necessary because after search I want to display the data, so I need to add it somehow either to model and view or to model. Return type, in this case, it's a string, non-model view. I could use model and view if I wanted to. It's fine. I just wanted to show that, remind you that there are two options. If return type is model and view, you add template name and data to the model and view. If return type is a string, you still can use data. In this case, you add data to model variable to achieve the same result. So this is second approach. So what should I have in the model? Definitely this data, result of the query, and also this data. This data. So I need to have some array to display this piece at the top. Of course, I could hard code it, but hard coding, if I hard code it, I cannot use loop. And if I cannot use loop, I cannot automatically select what is not linked. So the easy approach is to provide it as a data and to use loop. So for this reason, I created array, brute force, and this is array that is added to template. So model, add attribute, code letters, and this is what I added, code letters to the model. So I can run loop inside of the template to display this navigation bar. What is this one? Letters. So I add back to what is received. Okay. As what is received from here. Why? Because I need to do logic inside of the template to hide linking on this piece. So I need to know that what was selected in order to do this logic inside of the template. And definitely I need to have the list of the courses based on the search. So last thing is repository find by course start with. Remember at the previous lesson we learned that we can do searches by SQL, we can do search by example, or just encoding search in the name of the template, name of the method, and this is what was done. Find by, this is the name of the field, code, starts with, it's one of the options available by default, starts with, so search option, and this part. So if we open database, a database repository, we will see that this is just declared in the interface. So where is this course repository? Start with, and our system saw the name of it and implemented it in the code. So start with. And next method that I use it, start with additional parameter pageable. So also I declared that I want to have pageable option to retrieve data by pages. So in system implemented it. And this method is returning page of courses. So it's not list of courses, it's page of courses. A page, it's a wrapper that contains page size, page number, and actual data. So this is what I did for the searches. There is no search by word, although we could do such thing, like to make a search form and look for keywords from name of the course. I would leave it for your entertainment if you have extra time. We learned search by example or query by example at the previous lesson. It definitely requires extra looking up how to do it, but it's definitely possible. So consider this as entertainment if you have extra time to figure out how to do it. Okay, it is query by example. We discussed it at the previous lesson, close to the end. It definitely requires extra learning how to do it. I decided, okay, I'll skip it. Okay. So there is no query by example in this code at this moment. Maybe later, but not at this moment. So what happens in the template? A list template was used, a template used here is named list courses by codes. So let's open that, list courses by codes. List These courses by codes. Okay. So what happens at the top? I have a link to index. This goes to address/index. You saw this is. Okay. Next, I have a loop to display this horizontally. Right? So span letters. So this is wrapped in span because we need to wrap it in some kind of tag to repeat it, to use each. Span each in letters, and this is one at a time from this array. Okay. So what do I repeat? This is hidden from the template engine. It would be used only if you open this piece like this, directly HTML, like this part. So this. Okay. So it is hard-coded, a link to PROG. So this one list of courses. This. And what is this piece? I have a link. So this is a condition, right? So this link is inserted unless letters equal to selected letters. Right? So if letters are equal to selected letters, this link is not inserted. So what that means? If selected letters equal to loop variable letters, it doesn't insert link. Okay? So a link to where? A link to list code / letters. Right? So this is how to insert a link to template variable inside of template. So it is name of this variable, letters, and this piece, it is just loop variable. So this is template variable, and this is just loop variable. So this is template variable. Okay. And we have what opposite to if. We have opposite to unless. This is unless. It is if. Since if does not have else, we have to combine two pieces. In this case, in templates, it doesn't have else. We have to use two different tags. One is if, one is unless, which is opposite in this case. Okay. And this part, which is just the name of the letters, inserted as span without a link around, when there is a match between letters and selected letters. Okay. So it is opposite. A link is inserted unless they are equal, and no link is if they are equal. So this is the logic about creating this piece. And after this, I have just a list of courses based on that query. Okay. So extra step of complexity is manipulation of creating these links. When we open view page source, we will see actual links. See? Because this code is created on the server side, and browser received hard-coded HTML. Based on the template and the data. So in some place where selected is marked with match it, not market. Match it with variable in the loop, we don't have a link. This is math. And what is selected, it is just to make it bold. So I have a class in CSS to make it bold. this one. Bolder, not bold, bolder. So this is without pages. So the next step of complexity is how to retrieve data by pages and display it. So definitely it's a combination and it is more complicated. So let's see how it behaves. So go back to index and list by pages. So it is not codes by and pages, it is just pages. Code and pages, it is combination of two. Okay. There is also sorted and sorted by pages. So there is also sorting in this program, so it's also a combination. So let's see, list by pages. Since I didn't want to combine complexities right away, so I decided, okay, let's retrieve data by pages without query. So it is just pages. So how it behaves. When it is the first page, this link are not displayed. When we are at second page and further, it displays retrieving data by page number. And when we are at the last page, these links are disabled, so we don't have option to go beyond last page. So let's look at the mechanics at the top of it. So all requests are sent to list by pages and page number. And page number is one less than page number displayed here. As this page number is used in query, and in query pages are numbered from 0. And page number on the screen, it is logical page, and typically we don't number pages from 0, so it is displaying page number from query plus 1. Okay. So we already saw how to imitate link logic by creating and hiding links, right? So far in loop at the top. In this case, we didn't have to create a loop because we have only 2 links to hide, right? Two links here and 2 links here. So I use the same hiding and showing logic inside of for the links, but I don't have a loop. So let's see what happens when request comes to list by pages and question mark equal to this. This is not template variable. No, it's not path variable. So previously we saw path variables, right? Path, it's variable inside of the path. This is called request parameter. It is the same kind of request parameter that we'll receive when we submit data using form. So it is request parameter. Previously it was path variable. Now it is request parameter. Right? So obviously this piece looks totally different from this because we don't have a key question mark key value pair, right? So list by pages. So we're here. So list by pages, by default, as you see, it goes to page 1. Right? When we go list by pages, it goes to page 1. So let's see how it behaves. So course data controller, list by pages, and I didn't need to redirect because I can see, I can use default value here. I could also use default value courses, but PROG in that case without redirecting, but logic becomes more complicated in that case, so I decided to redirect. Also, I'm showing how redirection works again. So this is why it goes to first page. You see first page when I don't specify page number in the address. So as you see, I'm using default find all, and default find all comes with pageable option. So find all page request off, okay, parameter. And I fixed page size to 10 for simplicity. Although we could create drop-down list, page size, and specify it and use it in a cookie and retrieve page size from the cookie. It's another option. Why not? I decided to keep it simple. You probably saw page size from drop-down list somewhere, and probably store it in a cookie as your preference. Programs do store user preference in cookies. Where did I see it? When I go, for example, management class list, okay. So this is how it can be done, like page size drop-down list. But I decided, okay, let's keep it simple for now. So page size is 10 always. Okay. So what do I have here? A page, course page, find all, page off, and this. And in this case, I decided, okay, let's do it differently from previous one as a practice. So I'm returning model and view, list courses by pages, and in this case, it's page. It is not the list that I retrieved from page because I need page number to do page logic. And page object contains current page number, and size of the page, and so on. So this list courses by pages, this one has logic based on page object. So let's see. List courses by pages. Okay. And the top I need to have some logic to display links. If page number is more than 0, it means it's not first page. I'm creating links. So I will close this one. If page number is more than 0, content. Oops, sorry, it's the wrong piece. I'm displaying links, but this is 0, I'm not displaying it. So this is 0 page. Although it says 1, it is internally it is 0. Okay. So this is links. A link to the first page, a list by pages, and this is how to insert a request parameter. As you see, inserting request parameter is different from inserting path variable. It is different grammar inside of the template. Okay. So the first is always goes to first page, so p is equal to 0. Second, it is to the previous page, so page number minus 1, previous page logically. Okay. So this will be previous one. But when you are at the first page, these are not links. So unless page number more than 0, it is opposite to if. I created class disabled, which makes it gray, CSS class. That is displaying first and previous as gray. Okay. And also I have a logic to the next and last. So link to the next, it will be page p+1, it will be next. And last will be number of the pages, -1, right? So next will be a link to, wait, this. Next will be link to page number plus 1. And last will be page total pages, number of the pages minus 1, because last page number, it is number of pages minus 1 because it starts with 0. Okay. And opposite to that, to this if, it means we're at the last page. And how to know that we're at the last page? Page number, it is total pages minus 1, so it is last page. Okay. So unless it is less than total pages minus 1, links are hidden, right? So since it's opposite, unless, not if, it will hide links only at the last page. So it will display this in gray. Disabled, it's gray. So this is the logic of this navigation by pages. So these are links that contains data, which is page number. Okay. And next, index. A list all sorted. Similar idea, but ascending, descending sort. Okay. So this is a demo of using sorting information in the database query. Since I didn't want to combine complexity, I didn't use templates here. I didn't use pages here and navigation by course code. Definitely, we could combine both, and in this case, template will have more ifs in it. So logic is similar. You see that I'm using a request parameter in the link. I use the name of the request parameter d, and this is that. What if I do not provide list all sorted? It is using ascending by default. Right? So let's see it. In course data control, list all sorted. Here it is. Default value ascending, okay, D. So how did I retrieve it? So I created objects sort direction, and how did I create it? I use equals for this parameter for destination. Why did I use equals? Why couldn't you just use compare, equal, equal? This is feature or misfeature of Java. If we use equal sign, like equal, equal, to compare strings, it will be equal only if it is literally the same object, because it will compare addresses in memory. It will not compare content. In order to compare content, we have to use method.equals for the strings. So equal, equal does not work in Java to compare strings. So d equals descending, and if it is descending, I'm using this. So I use question mark operator. When condition is true, use first one. When condition is false, use this one. Okay. So sort comes with predefined object, direction dot ascending direction. So this will be direction. Okay. So I create sort object by sort by direction and two additional fields. So it is not just direction, it is also code and name specified, right? So when we specify direction, we need to specify what is the field we are using in sort, right? And you can specify more than one. It will use the first one. After this, it will be the second one. So it's a demo of using more than one for sorting. Okay. So now we have a sort object, and we do repository find all based on the sort. Okay. So when I display it, return value is string, so it's template variable. So to the model, I need to add two values. I need to add list of the courses to display, this, and I need to add direction. Why? To disable this link, the same logic. So when I click on descending, this link is disabled. So logic is similar in the template. Right? So when we have these things equal, link to this, not link. This element equal to that, this is not link. Okay. So let's see that piece. List all courses sorted. So if direction is equal to ascending, this is not a link. First is not a link, but second is a link. Unless means opposite to if, first is link, but second is not link. Because I have two options, I don't need to create a loop for that. I just have it on the list. And after this, just previous loop as before, but just with different data. So this is option how to do sorting, and combination of it, all sorted, list all sorted. Combination also, there is combination of code and pages, which is and sorted by pages. It's also combination of sorted and pages. So when we go into template, it is just combination of the same logic. When we go into controller, it's also combination of these two logic. Okay. So just combining complexity. So when we need to write complex code, it really makes sense to check it separately and combine it afterwards. This is what I did in this example. Okay. So list codes by pages, I have pages logic and code logic. So template combines these two options. When I go to sorted by pages, I'm combining sorting option, logic, and page logic. And we can also combine all three, which would be brain twister, but we actually can do that, right? If we're careful, it will be all three. We can also combine logic by page size at the bottom. It's also additional logic. So in this case, yeah, if we need to make something complex like this, searches and page size logic as well, first we check it without the logic, make sure it works, and we add it. So it's always, all programming, it is incremented complexity. So we check features separately, combine them, and so on. Questions? No? So we have about half an hour till the end, and I want to wrap it up because explaining combining logic, it is just combining. It's not anything extra. It is just the same thing from two templates together, put carefully together. So play with it, and if you want adventure, add page size option. Yeah, store it in cookie. It's definitely adventure. If you want one more adventure, add search option based on keyword in the name of the course. Definitely, it's another adventure, and this is a bigger adventure because this is a query by example mentioned in the previous lesson. Here it is. Example is possible to do, but if you need to do it, learn details from documentation. This is what happened to the previous lesson. So in this case, search by keyword in course name would be big adventure. And this will be also page size. It's also big adventure. So also adventure because you will need to deal with cookies to store page size like user preference in a cookie. Okay. Questions?